The next topic is using a Java semaphore to coordinate the way in which threads get scheduled and execute. And so the previous example we looked at used semaphores to share or mediate access to shared resources. This would be used to coordinate the order in which the operations occur. And this case is going to be motivated with the ping pong example. So this particular app, and you can find different versions of it in different parts of my code base, will coordinate interactions between two threads. One is a ping thread, and the other is a pong thread. And if you're a student or a historian of video games, you'll know that one of the very first video games from, probably 40, 50 years ago was the game Pong, where you could play it on your TV set and it would basically do pinging and ponging back and forth. So this is kind of a nod to that classic video game. And what we have here is we have two threads that are alternating, printing ping and pong on their display. And they need to use these semaphores so that they alternate. So the first thread prints ping, and then the next thread prints pong. And then they go to the next iteration. And the first thread prints ping, and the second thread prints pong. And they go back and forth and back and forth. So here's essentially how this could be implemented using semaphores. And what we're going to do here is we're going to have a pair of semaphores that coordinate the order in which pinging and ponging will run. And that allows them to play ping pong. So you can see on the interaction diagram or the sequence diagram, we have a ping semaphore and a pong semaphore. So the way this works is we start off something called the play ping pong thread, and that will then itself start two other threads, a ping thread and a pong thread, and they're the ones that will alternate printing ping and pong. Here's what it looks like under the hood. The actual implementation, if you go and look at the source code, and we will probably look at the source code later in the class, is to use the so-called template method pattern, which is a classic gang of four pattern where you define the skeleton of an algorithm in one method, and then you defer the actual implementation of so-called hook methods or primitive operations to subclasses. And that's exactly the way that our solution works. So once the ping thread and the pong thread start to run, then they will go ahead and alternate their behavior by using these semaphores. And the way this works is that the ping semaphore starts out having an initial count or a permit count of 1, which means it's not acquired or it's available. And the pong semaphore starts out with an initial value of 0, which means it's locked or acquired. And the way that we do this, of course, is to make sure the ping thread goes first, followed by the pong thread. That's why we initialize them the way we do. And here's what it looks like. The first thread, the ping thread, will start out and they both run the same logic. They both go through a loop where they acquire and release the semaphores, except that both objects acquire and release the semaphores in opposite order. So the ping thread will go ahead and acquire the ping semaphore. And you can see when it acquires the ping semaphore, it'll get it because it starts out not acquired or unlocked. It'll then print ping, and then it will release the pong semaphore. And when it releases the pong semaphore, what that does is that lets the pong thread, which has been blocked trying to acquire its locked semaphore, that'll let it acquire the pong semaphore, print pong, and then release the ping semaphore. And so they go back and forth, acquiring and releasing each other's semaphores. This is a nice example because it illustrates the use of semaphores in a non-fully bracketed manner. So it can be the case that the thread that acquires the semaphore is not the thread that releases it. Notice you can't do that with reentrant locks, which must be fully bracketed. So that's one of the ways in which those two synchronization mechanisms differ. And the way that we do this is that if you look at the code, you can see that acquire the acquire hook method calls the acquire method on the semaphore that's the my semaphore, which is the ping semaphore for the ping thread, and the pong semaphore for the pong thread. And then it will go ahead and have the release method release the other semaphore. And that's how they go back and forth coordinating in this particular model. People usually ask, can we get by with just one semaphore to do both these things? And the answer is no, you have to have two. Once everything's done, the ping thread exits, the pong thread exits, and the play ping pong thread will join with the the termination of the other two threads. So that's a nice example of barrier synchronization for the play ping pong thread. So that's the end of the overview of how you can coordinate threads using a Java semaphore. And give me 1 second here. I'm going to let my dog out. He gets impatient.